So we'll take a small example. So if you remember our first example, what is that here? We took x of t to be what? E power minus at u of t, correct? So you, and what is the constraint we put on a is greater than 0. So for this, x of j omega equal to how much here? We got that to be 1 by a plus j omega. Okay, note that the given signal x of t is real. So definitely what should happen to the Fourier transform? We'll write down that. Note that x of t is real, correct? Okay, that implies what? X star of t is equal to x of t. X star of t equal to x of t. If you take conjugation of x of t, you get the same signal. So definitely the signal is real. So what should happen? X star of minus j omega we have to find out. Okay, so we have to find out x star of minus j omega. So let us first write down what is x of j omega. What is x star of j omega? So this will be 1 by a minus j omega. Is that okay? 1 by a minus j omega. So from this, what will happen to x star of minus j omega? That should be equal to 1 by a plus j omega, correct? Wherever there is omega, replace with minus omega. We'll get 1 by a plus j omega, which is same as our x of j omega. So that's what we have proved, correct? Fourier transform should satisfy which property? Conjugate symmetry property. What is that? X star of minus j omega. We got that to be x of j omega. Okay, right. And also, if you look at our Fourier transform, which is 1 by a plus j omega, this fellow, if you multiply and divide with a minus j omega, what you get? You will get a by a squared plus omega square minus j omega by a squared plus omega square. Is that okay here? You multiply and divide with a minus j omega, you can split the final result in this form. That is simple basic algebra. So what is real part? Okay, so what is xr of j omega here? Real part of the Fourier transform is how much? It is a by a squared plus omega squared. So which is same as what? xr of minus j omega, correct? Why? If you replace omega with minus omega, you get back the same signal, and hence what does it mean? Real part of the Fourier transform is even. And similarly, what happens to imaginary part? You have imaginary part, right, which is xi of j omega, which is equal to how much? Imaginary part would be minus omega by a squared plus omega square, and you can easily show that this is equal to minus x of minus j omega. Replace omega with minus omega, and finally you multiply with minus 1, so you will get back xi of j omega. This implies what? This implies imaginary part is odd. Okay, what is it we have got here? We got that Fourier transform is conjugate symmetric, and we got real part to be even, and we got imaginary part to be odd. Now let us talk about magnitude. Okay, so to check the magnitude, we got, I write down again so that it is clear. We got x of j omega to be how much here? 1 by a plus j omega. Okay, and this we wrote it as what? A by a squared plus omega square minus j omega by a square plus omega square. So what is modulus of x of j omega? That is nothing but 1 by root of a square plus omega square. So modulus of denominator is root of a square plus omega square, and you can easily see that this is nothing but modulus of x of minus j omega, right? You replace omega with minus omega, it doesn't change, you will get back the function. So this implies what? Magnitude of the Fourier transform is even. And what happens to angle? What will be angle of x of j omega here? That is nothing but tan inverse of imaginary part by real part. Imaginary part is minus omega by a square plus omega square by real part, which is a by a square plus omega square. So a square plus omega square will get cancelled out. So you will get tan inverse of minus omega by a. Okay, so this is our angle of x of j omega. So we have to check what will happen if you take minus angle of x of minus j omega. Okay, so this should be equal to how much? That should be equal to our x of j omega, angle of x of j omega. Why? Angle of the Fourier transform or face of the Fourier transform is odd. So minus angle of x of j omega should be equal to our angle of x of j omega. Let us see whether we will get that or not. You will get minus tan inverse of omega by a. Correct? So minus is there. X of angle of x of minus j omega is tan inverse of minus omega by a. So angle of x of minus j omega means minus omega should be replaced with plus omega. Okay, so you'll get this one. But if you send minus inside, so this is nothing but tan inverse of, correct, minus omega by a. So clearly this is equal to how much here? This would be equal to, okay, so that would be equal to angle of x of j omega. So what is it we have seen? We have seen that angle of x of j omega is odd. Okay, that is odd. So till now what is that we have seen here? For the given example, we are checking whether it satisfies all the properties or not. So clearly it is satisfying, right? So we took x of t to be e power minus at u of t, which is a real signal, and hence Fourier transform should satisfy conjugate property that we have seen. And because it is conjugate symmetric, correct, Fourier transform should be conjugate symmetric, and because it is conjugate symmetric, we have proved that its real part is even and its imaginary part is odd, and also we have proved that its magnitude is even. Correct, modulus of x of j omega is same as modulus of x of minus j omega, and its angle is odd. Okay.